Hello everyone. In this video, we're going to be solving a problem, a number theory problem with fractional part. So we have the fractional part of 30x equals the fractional part of x. And we're going to be solving for x values. Let me explain what the fractional part of a number is first. In order to understand the fractional part, first we need to talk about the greatest integer function, which is also known as the floor function. So anytime you have a number like, let's say, 3.14, which is kind of pi, right? You can think of this number in two ways. Well, it's made up of an integer part like 3 and a 1.14 as the decimal part. This decimal part is called the fractional part, which we denote with the notation, the curly braces. And this part, which is the integer part, is called the floor value, and our notation is going to be something like this, which indicates the floor value. In other words, when you round the number down to the nearest integer, you get the floor value of that number, okay? So that's how fractional part works. Of course, this gives you kind of like an interesting identity. X is made up of its floor value plus the fractional part. Make sense? So this is going to help you solve many of these problems. So basically, we're looking for two numbers so that when you multiply by 30, the fractional part does not change, which is something interesting, and we'll talk about that later. Now, let's go ahead and see if we can use this identity to solve this problem. So we're going to go ahead and evaluate both of these. First of all, obviously, you want to isolate the fractional part from here. You can write it as x minus the floor value of x. In other words, you can define the fractional part as the difference between the number x and its floor value, or the greatest integer function. So in this case, it will be 3.14 minus 3, which gives you 0.14. So this shows you that the floor value of any integer is going to be any number, the floor value of any number is going to be an integer, and the fractional part of x is always going to be between 0 and 1. Why? Because if x is an integer, then their difference is 0, obviously. But if x isn't an integer, like 3.14, then the fractional part is always going to be the decimal piece, which is less than 1, obvious, right? You don't want it to be greater than or equal to 1. So this is great. Let's go ahead and see how we can solve this problem using this identity now. Now, what was our original equation? The fractional part of 30x is the same thing as the fractional part of x. How is that possible? You multiply a number by 30 and you still get the same decimal part, right? All right, let's see how this can happen. Now we're going to use this identity. So we're going to replace the fractional part of 30x with what? The floor value, right? It's going to be this one, x minus the floor value. So we're going to write the x first, which is 30x in this case. So it's going to be 30x minus the floor value of 30x. And then that is going to equal x minus the floor value of x. Great, this is helpful. You know why? Because we can actually put the x's on the same side. So let's go ahead and do that. I will actually bring this over here. So that's going to give us 29x. I'm going to add this to both sides. And the floor value of 30x minus the floor value of x. Of course, you're not allowed to subtract. So in other words, the floor value of a minus the floor value of b does not necessarily mean the floor value of a minus b. In certain cases, this can happen, obviously, when a and b are integers, but not all the time. So what can we do to simplify the right-hand side? Nothing, because we don't need to simplify that. Make sense? Okay, let me show you. Now, one thing that I told you about the floor value, what was that? It's always an integer. That's cool. That information is super helpful. Notice that this is an integer and this is an integer. So what do you know about the difference of two integers? That's also an integer. Great. Then 29x must be an integer, right? What's that supposed to mean? Well, if n is any integer, say n is an integer, an element of z for Zahlen, so 29x is just going to be equal an integer n. But wait a minute, aren't we still looking for x? We are. All you have to do is then just divide both sides by 29. So x can be written as n over 29, where n is any integer. So this is basically going to give you all the possible values of x. Well, what is that supposed to mean? For example, if n is 0, then x is 0. Does that work? Absolutely. Take a look at this. We have the fractional part of 30x and the fractional part of x, but they're both equal to 0. Because in this case, x happens to be, and of course 30x as well, happens to be an integer. So yes, they're equal for n equals 0. What about n equals 1? Let's take a look. That's a more interesting case. X is going to be 1 over 29, and 30x is just going to be 30 over 29. Now, how can we explain or prove or show that the fractional parts of these two numbers are equal? Easy. You can actually go ahead and write this 30 over 29 as 1 plus 1 over 29. So notice that the fractional part of x, which is itself in this case, and the fractional part of 30x, which is 1 over 29, which is the same as x, they're equal. That's interesting. So if you have a number between 0 and 1, its fractional part is itself, because you can write that number as 0 plus 1 over 29. In this case, the floor value is going to be 0, because this number is between 0 and 1, its floor value is going to be 0. Make sense? Okay, great. So this basically gives us all the solutions, but what is 1 over 29 equal to? You don't really care. And if you really want to know what that looks like, you can go ahead and divide 29 into 1. Obviously, this is going to be a repeating decimal, an interesting one. 29 doesn't go into 1, so we're going to put a 0 with a decimal. Now add a 0 here. 29 doesn't go into 10, so we're going to add another 0 and another 0. Now 29 goes into 100. Not 4 times, 3 times. 3 times 29 is 87. You're going to get a remainder of 13. And then you are allowed to add zeros because we already have a decimal here. So it's all good. 130 into 20, 29 into 130. Let's think about it. 5 times is going to be, I think, too much. 4 times is going to be 116. So 4 times is going to work. That's 116. The remainder will be 14. Add a 0. In 140, if you put 5, that's going to be 145. Too big. So you're going to have to go with 4 again. And that's going to give you 116 again. The remainder this time is going to be 24. Add a 0, and you're going to get a larger number. Do you think 9 is going to work? I don't think so. That's probably too big. Wait a minute. 9, I think, is going to work because it's 261. Nope, that's too big. So it's probably 8. Let's check it out. Yeah, it's 232, exactly. So it's going to be 8, and then you're going to get a 232. Remainder will be 8. As you can see, we're going to have a lot of digits that repeat, and this is going to continue. Of course, at some point, you're going to have a repetition, or you're going to have a pattern. But that's going to be a long time before we get there, okay? But you get the idea. No matter which number you take and divide, you're always going to get the same number. So what happens to 30x in this case? It's just going to be 1 plus this, so it's going to be 1.03448 ... But again, their fractional parts are going to be equal. Now, is there another way to solve this problem by setting these equal to something? Possibly. Like you can say, okay, suppose this is equal to k. And then in this case, because the fractional part of x is equal to k, you can basically write x as n plus k, where n is an integer. And then you can do the 30x. 30x is going to be 30n plus 30k. But then the problem is you kind of need to find the fractional part of this expression and then set it equal to k, and so on and so forth. Anyways, this brings us to the end of this video. Thanks for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care, and bye-bye.